Suppose you want to find the 3 cheapest flights to Tokyo next month. Check your loyalty points to see if they cover the fare, and book the best option. If you give this prompt to a standard large language model, it will generate a highly detailed, step-by-step explanation of exactly how you should accomplish this, but it will execute 0 of those steps. This happens because a standard chat interface is stateless. The model predicts the most statistically probable next word, finishes its sequence, and immediately halts processing. When you send a new prompt, it processes that text in complete isolation. It has no persistent memory of the previous step, nor any built-in mechanism to act on the plan it just generated. This inability to sequence decisions across time has nothing to do with the intelligence of the underlying model. It is a strict architectural limitation. To achieve actual automation, software development is abandoning the single-pass response cycle. The requirement is an architecture built to act, observe results, and persist until a task is complete. The highly autonomous systems used by enterprise developers to write code or manage operations are powered by the exact same base models behind simple consumer chatbots. The neural network does not define the difference between a chatbot and an autonomous agent. The software architecture wrapped around the model dictates that behavior. That architecture relies on a specific programmatic mechanism, placing the language model inside a continuous while loop. Instead of halting and waiting for a human to provide the next instruction, this loop forces the model to continuously evaluate its own previous output. This shifts the system from a passive linguistic simulation into an active reasoning engine. It generates an idea, tests it, and uses the result to decide what to do next. By trapping the model inside this invisible loop, the software crosses the threshold from generating static text to executing autonomous, multi-step workflows. This transition is formalized in an equation outlined by AI researcher Lillian Wang. It states that an agent equals a large language model plus memory, planning, and tool use. The execution of this formula happens in a strict 5-stage cycle. First, the system perceives its environment by ingesting data. Then, it uses the language model to reason about that specific context. Next comes the planning stage. If the overall objective is complex, the system programmatically decomposes the goal into a series of smaller, discrete subtasks. With a plan in place, the system acts. It executes a specific tool, like querying a database or running a Python script, to address the immediate subtask. Crucially, it then observes. The raw result of that action is captured, formatted, and fed directly back into the model's context window. A while not done loop ensures these 5 stages repeat iteratively. The loop terminates only when a specific stopping condition has been met. Because each step relies on the observation of the previous action, the AI dynamically reacts to errors or changes in real-world data, rather than guessing blindly from a single prompt. To manage this rapid execution cycle, developers rely on specific routing logic. The most prominent is the React paradigm, which interleaves reasoning with acting. It begins with the thought phase. The agent identifies missing information. That thought translates into the action phase, creating a command for an external tool. It communicates using standardized JSON payloads. The tool sends back an observation, updating the internal state. This explicit cycle forces the model to verify its logic against external databases at every step. Consequently, the rate at which the model hallucinates false information drops significantly. The React framework effectively turns the language model into an active, self-correcting API router. However, React operates sequentially. Strategic planning tasks involving many dependent choices often require more than a linear approach. To solve these multi-path problems, architects deploy the Tree of Thoughts framework. Instead of committing to a single path, the system generates and explores multiple distinct reasoning branches simultaneously. During simulation, search algorithms scan these branches horizontally, evaluating the potential success of each independent path. If a branch produces a logical contradiction, the backtracking mechanism triggers. The agent abandons the dead end before committing any computing resources to an expensive code execution. By simulating multiple outcomes and selectively pruning failures, Tree of Thoughts provides strategic foresight. The system identifies optimal solutions by testing options across branching decision trees. Even with advanced reasoning logic, an isolated engine remains useless if it cannot interact with secure enterprise infrastructure. The standardized bridge allowing this interaction is the Model Context Protocol, or MCP. MCP servers act as secure translators. They allow the JSON outputs generated by an agent to execute database queries, retrieve live analytics, or manage file directories. In a multi-agent flow, a central orchestrator can delegate a specific task to a specialized subagent. That subagent then uses an MCP connection to securely manipulate the relevant database. This standardized protocol provides the crucial link. It allows reasoning engines to escape isolated sandboxes and execute side-effect operations on enterprise data. This architecture is the catalyst for a shift in tech industry economics. Software can now replace functions that traditionally required large, expensive teams. A solo founder using agentic loops replaces 70 to 80% of a traditional company's salary burn, with tool subscriptions costing roughly $500 a month. By mid-2025, solo-founded startups surged past 36% of all new ventures, creating the Vibe CEO framework. A single founder focuses their time exclusively on high-level strategy and vision, while directing a fleet of specialized sub-agents to handle the tactical execution. The founder's daily role shifts entirely. They no longer manage human employees, but manage the context windows, prompts, and routing rules governing autonomous loops. By mastering the agent loop, a single developer can yield the operational output of a 15-person enterprise. But deploying these while loops in production environments exposes severe vulnerabilities. Without strict architectural constraints, autonomy is incredibly fragile. A primary risk is the runaway loop. If an external API breaks and an agent lacks a hard stopping condition, it will repeatedly query the broken tool, trying to solve the problem indefinitely. Multi-agent systems can consume up to 15 times more tokens than standard chat interfaces, burning through budgets in minutes if left unchecked. Beyond technical errors, these systems introduce a liability gap known as the moral crumple zone. When an agent fails in a complex edge case, accountability becomes dangerously diffused. Developers, managers, and software vendors point fingers, leaving human operators to absorb the legal blame for opaque machine decisions. The legal courts have already established a precedent for this. A Canadian tribunal held Air Canada liable when its AI assistant provided incorrect fare guidance to a customer, resulting in direct corporate liability. Deploying autonomous agents without hard programmatic guardrails and clear liability structures creates immense financial and regulatory risk that no business can ignore. Artificial intelligence has transitioned into a proactive operating system. The actual capability of these systems lies not in the neural network alone, but in the programmatic loop that binds those neural pathways to the software environment. Understanding this invisible architecture is now a mandatory requirement for anyone attempting to build or manage scalable software. Organizations that ignore the loop will be outpaced by systems that iterate, test, and act continuously while their human competitors sleep. The core skill of modern development is architecting the agent's autonomy.